In this video, we're going to be looking at the inverse of a quadratic function and the sketches. Okay, perfect. Remember, a quadratic function is basically a parabola, and a parabola is a one-to-many function, right? Remember from the relations video, we said a parabola is it's a many to one function, right? It's a many to one function. So its inverse is going to be one to many, which is not a function. Remember, anything to many is not a function, which means we cannot represent the inverse in form of h minus 1 of x. Ne? We cannot represent it in function notation. We're just going to represent it with y equals 2. Okay, perfect. So now let's do the inverse. Ne? So inverse, remember the first thing, you switch your y. Remember, this is your y. You switch your x and y, right? So where there was y, you put x. And where there was x, you're going to put y. So it's going to be 3y squared. Okay. And then we need to isolate the y. So I'm going to divide by 3 both sides. So I have y squared equals to x over 3. And then I therefore need to introduce a square root both sides. So that squared equals to plus minus square root of x over 3. Therefore, y equals to plus minus square root of x over 3. This cannot be written as h minus 1 of x because it's not a function. They only use the function notation for functions. Okay, perfect. So we're just going to leave it as y equals to. Ne? Sure. And then now we're going to sketch this graph and its inverse on the same set of axes as the question instruct us there. Okay. Sure. So I already sketched this on a graphing calculator. Let's see how they look. So basically, this guy here is our h of x. This guy here is our h of x, which is our parabola. And this guy is the inverse, ne? Which is y equals to plus minus x over 3 inside the root. Okay, perfect. And then guys, when you sketch a function and its inverse, now you're always going to show the axis of symmetry line, which is always y equals to x. Ne? And you always represent it with dotted lines. Here is because I just used the graphing calculator, but in the exam, just use dotted lines to show that it's axis of symmetry. Remember, asymptotes and axis of symmetry lines, you show them with dotted lines. Right. And then we're done answering this question. Let's go to the next question. Okay. So on the next question, they want us to determine the inverse of q of x and sketch both on the same system of axes. And then we're going to restrict the what? Let me just highlight this. Restrict the domain of q so that its inverse is a function. Okay, we'll discuss this later on. Let's firstly get the inverse. Remember, this guy here is y, that guy is x. So to do inverse, we switch, right? Where there was y, we put x. Where there was x, we put y. Then we want to make y the subject of the formula. So you're going to divide by 7 both sides. So here you have x over 7 equals to y squared. And then we're going to have, therefore, square root of y squared equals to plus minus square root of x over 7. Therefore, y equals to plus minus square root of x over 7, right? And then this graph cannot be written as q minus 1 of x because it's not a function. So it cannot take a function notation. So you'll just leave it as y. only the graphs that are functions can be written in function notation. And the inverse of a parabola is not a function because it looks like this. So it's going to fail the vertical line test. Okay. Perfect. So the vertical line test fails here. Sharp. Now let's go to sketching. We sketch them here. So this is basically our P of X. Q of X is this guy here. Right? You show arrows to show that they keep on going. Arrows everywhere. Okay. So guys, I sketched there. This is our function, and this is our inverse. Ne? Remember, to get the inverse, it's easy. The function's turning point is 0 and 0, right? And then you keep whatever points was here, you just flip them, and then you'll get this nice graph here. Ne? Perfect. Then you always show the axis of symmetry lines. The axis of symmetry lines, which is shown in dotted lines, and then you show that this is y equals to x. You show that this is y equals to plus minus is going to be x over 7 inside root. Ne? Sharp. Now we need to restrict the domain, right? So that, remember, let me show you something. The inverse is not a function. It fails the vertical line test because it touches there and there, right? So we want to try to make this guy function. Ne? So check. You need to know which part goes with which. Ne? This part, which is the part on the graph, right, is the exact mirror image of this part on the inverse, right? Because they are reflected there. Then you can see that this guy here that I'm dotting, will be the exact same mirror image with this one. Ne? Sharp. So to restrict the domain so that this becomes a function, you always restrict using the x value on the turning point. So you're going to say x must be bigger or equals to 0, because check, if x is bigger or equals to 0, you are only talking about this part here. Ne? So it means you excluded that part basically. And if you're excluding this part, talking about this part only, the inverse part will just be this side. This guy is not there. So when you do vertical line test, it passes now. So the inverse is a function. Or x must be less than or equals to 0. If you do less than or equals to 0, you are doing this part basically, where the x value are negative here. And if you are doing this part, it means when the inverse, you are only focusing on here. So those two guys there won't be there. You see? So which means the inverse is going to also be what? A function. But in simple terms, when they say restrict, my experience tells me that the answer is always the same. It's always x is bigger than 0 or x is less than or equals to 0. Right? But in simple explanation, you're always going to go to the x value on the turning point and say x is greater or equals to that value. If it was 2, you're going to say x is greater or equals to 2, or x is less than or equals to 2. Does make sense? And that's it about this video, ladies and gents. I hope it made sense. Please feel free to subscribe and share with family and friends. Thank you. More content is coming.